his PhD in geography with his research interest as groundwater modeling, climate change, natural hazards, flood and drought, land sustainability modeling, sustainable agriculture management. His research focuses on utilizing advanced techniques and technologies to address various environmental challenges, particularly in the domains of flood susceptibility, mapping, landslide prediction, drought assessment, and groundwater management. We feel very lucky to have you, sir. Please continue.
Uh, Thank you, Megha Madam. Am I audible?
Audible, sir.
Thank you. Thank you, Megha Madam. So let me share the screen first. I guess my screen is visible, right? Good morning, all the dignitaries, organizers, fellow researchers and participants. My name is JayantaDas. I am from West Bengal, from Ramford College. My background is geography. And thank to the organizer for inviting me, for giving me this opportunity for today's lecture on improving early season crop type mapping using machine learning algorithm with combining SAR and optical time series data. I thankful to the organizer of International Conference on Civil, Environmental and Applied Science, organized by Department of Civil Engineering in association with the Department of Basic Science and Humanities, Bhubaneswar. So basically, I have chosen this topic. Why? See this term, early season crop type, right? Early season crop type, that's when it's required now. In early season, we have to predict how much crop to be grown for a nationwide. Because then government take the decision. If it is any deficiency in crop, any crop type, then government have to import from the other countries. If it is exceed, then we can export it. Not only this, for minimum support price, government have to decide how much crop to be grown in any season. It may be in Rabi season, it may be in Kharif season. But in earlier, it was very difficult to prepare the crop mapping or estimate how much crop to be grown in this season. That's why we face very difficulties. Now we are in an era, in digital era, we can use the satellite data. So here I have used two freely available satellite data. One is Sentinel-1 data, that's a SAR data set. Another this optical data set, that's the Sentinel-2 data set. Both are 10-meter resolution. So we can prepare highly accurate map for any crop type. So let's discuss about first my objectives. I have taken three objectives. Basically, my objectives is to assess the accurate crop classification, combining this SAR and optical data set. Say, in case of Rabi season, obviously we can use the optical data set, but in case of Kharif season, in rainy season, we don't have the optical data, so we cannot prepare without SAR data. But here I have used the SAR data in Rabi season to improving the classifications. I have used two machine learning classifier, one random forest and another gradient bushing 2. So here I have evaluated these two data set basically SAR, then optical, and another data set I have used SAR and optical. So I have prepared third data set, right? Then I have tried first one, I have tried Stallion on SAR, then Stallion on optical, then I fuse it. I have considered three date 1, date 2, date 3. First I tried minimum data set, how we can use with the minimum data set. So first data set, date 1 with SAR and optical, then date 1 plus date 2 with SAR and optical. Then I have tried with the three dates. And you can see this is a study area. I have considered the Udham Singh Nagar districts of Uttarakhand because this is one of the agriculture bowl of Uttarakhand districts, and soil suitable climate condition, fertile soil is there. That's why this is a agriculture dominant district. In Rabi season, there are three important crops: wheat, mustard, and sugarcane. So for any remote sensing analysis, we need ground truthing data. So I have collected this ground truthing data like for urban land 100 points. This is a point data, see here. Then forest 100 point, water body is 100 point, wheat 482 points because this is a major crop here. Then mustard 100 point, sugarcane 95, and river bed 164. So this 7 category, basically my target is to recognize or mapping wheat, mustard, and sugarcane crop in early season. So this is the data set I have used. For SAR data set, I have considered both VB and PAs, that's the vertical and vertical horizontal polarizations. And I have considered informative wide swath mode. And here I have considered descending pass. We have 2 types of data, descending and ascending pass. I have considered the descending pass, right? Then optical data. So SAR data, spatial resolution 10 meter. In case of optical data, I have considered band 2 to band 12. That's the 10 bands. So spatial resolution 10 to 20 meter. And that's why I have resampled it into 10 meter, because I have 10 meter resolution SAR data, 10 meter resolution, most of the bands of optical 2, central 2 data. Like this is the time frame you can see here, November 10 to 15, just early growth period of Rabi season, November 10 to 15, then November 25 to 30, then December 15 to 20. So we can say when the March month, the crop yield, how much crop will be grown and how much yield we will have. So we can predict our crops, right? So total 1,141 sample points we have across the 7 classes. Now coming to the methodology section, this is most important part. As I mentioned, I have considered both data sets, Central 1 and Central 2. For Central data set is a SAR data set. I have considered VB and base. Now this is most important part for speckle filtering, because in case of VBPS we need to filter it. So I have considered here enhanced leaf method for speckle filtering for enhancing the data set. Then Central 2, I have considered B2 to B12, and here we need cloud masking. This is most important. And here I have used QS60 dataset to improve this dataset. So we can improve this dataset using optical dataset using quality assessment 60 band. So using this band, I have improved this dataset. Then I have considered this 3 time period, date 1, date 2, date 3. Then I have used these 2 machine learning method, RF and GBT. For RF, I use only the Sentinel dataset, the Sentinel 1, then Sentinel 2, then fuse it, Sentinel 1 and Sentinel 2 in 3 way. And then similarly for GBT, then I have checked the accuracy. This is important part. I have calculated the confusion matrix, overall accuracy, then recall, then precision, kappa occupancy, F1 score. Then I have checked altogether. I have 36 bands. Which bands are important? Then we can take the decision. Comment take the decision after preparing this, right? So coming to the methods. So my training, my ground truthing data set, I have split it into 2 groups: 80% for training purpose and 20% for testing purpose using the random sampling technique. And for classifier technique for random forest, I have considered 100 trees, but this is the optimum level. Okay, I have tried, because it's a land-based model, so I have tried in various combination, 100, 150, 200. Like this was 100 trees is optimum for this region. And for GBT, 150 trees optimum, and shrinkage was 0.1, right? So here the band combination, as I mentioned. And in this work, I have used 3 software: GE, ArcMap, and Google Colab. So see here the NDPI for 3 time series. This is the first time series data, the second time series, and third time series. See this higher value of NDPI in green color, higher value. Here also the same. Here also some. So we can say that these are the forest land, and here the dark color, blue color. See, in all the season it is same. So we can say these are the water body. So higher value mean forest and lower value mean water body. But in between these are the defined thing. These are the agricultural land. See here. See, it is less, then it is increased because it is showing period, that's why it is increased. Now it is decreased in December. That means these are the agricultural land with some phases of build-up area. And see, this is the NDPI temporal profile for each crop, like wheat, then sugarcane and mustard. See the mustard crops. NDPI value is very less. So we can say these are late mustard crops. So this is basically showing period here. But in case of NDPI of wheat and sugarcane, because sugarcane is a grown throughout the year. So that's why it is very high. See, this is very high. Also for wheat, it is high. So now this is actually the harvesting period. That's why NDVI again decrease. So based on this understanding of NDVI relation with the NDVI and SAR data set and other data set, we can build the model. Here, first one I will discuss about the gradient bushing tree. First one I have considered the SAR data set. I have prepared this model for SAR data set. Then for central data set, and I fuse these two data set, SAR and central. So here, check it here for this area. See here for central two data set. These are the forest land, but central one data SAR data set cannot recognize the forest land properly, right? See here. So that's why in case of forest land, using the central data set, it was only 14.94, but when we use the central 2 data set, it was 23.77. So we can say central data set cannot properly classify the forest land, but in case of optical data set, it is the NDVI technique. We can easily recognize the forest land using the optical data set, right? Then we fuse it. Now, see here the wheat crop, mustard crop, and sugarcane crop. Wheat crop, 50% of area measured by central 1 data set. Central 2 data set, it is close, 51.75. Then we fuse it, it was increased by 2 points, like 53.59. But mustard crops, it was 3.88, but it is increased double, 6.94 when used the central 2 data set. Again, it is decreased 4.46%. Then sugarcane, 17.39, now it is decreased for 9.49, and when we fuse it, it was 9.79. So I can say that we can use central 1 data or central 2 data, either central 1 or either central 2 for preparing the wheat crop. It is very easy to classify it, but for mustards and sugarcane, it is very difficult to prepare using only the central 1 or central 2 data. That's why we need to fuse. If you see the other method like RF, you can see here also in case wheat crop, it is near to 50%, 47.96, 48.82, then 51.84. So it is more or less same. But in case of mustard, it is not same. See here the 2%, then 6, it is increased again 6.46, then it is increased again 6.11. Right? For sugarcane, 18% using the SAR data set, and 10% using the optical data set, and it is around 10% when you fuse these two data sets. So it is very difficult to find out the sugarcane and mustards using the SAR data set. That's why we need to fuse. If you see the validation, this is the important part for validation. So here, I want to discuss which method and which data set is appropriate for classifying various techniques. Like, so see here the GBT. In case of SAR data, when I consider the SAR data, I got the overall accuracy 0.68%, so 68% accuracy. When I use the RF technique, it increased near about 74%. So it's increased by 4%, right? So if we want to use the SAR data, then RF is better than the GBT. And for central 2, see, if we want to use the central 2 data, optical data set, obviously, I got 90% accuracy. Instead of here, the RF technique, it was only 0.81, so 81%. So I got 9 point higher accuracy using the GBT. So decision is, if you want to use the SAR data set, then RF is better. If you want to use the central 2 data set, optical data set, then GBT, it will get better result, right? Then I fuse these two data set into 3 combination using the first state, here about 90%, here 87%. Then we fuse 2 date, then 88%, here 85%. But when we fuse with the 3 date, we got similar result, 93% for GBT and 93% in case of RF. So if we want to fuse the optical and SAR data set, then we can use any technique GBT or RF, there is no difference. Okay. Now coming to the class-based discussion, class-based accuracy. So here PM in producer accuracy, we can call it the recall, and UM in user accuracy, we can call it precision, right? And F1 score. So based on this F1 score, see, in case of urban, see F1 score for settle one data 0.58. In case of GBT, this is GBT, right? And here for settle two data, it is 0.88. Then when you use the first date combine 0.94, then when you combine two date 0.87, when you combine three date, it is perfect match 1. So it is a perfect match for forest and for the urban land when you fuse settle one data, SAR data set, and optical data set. Okay, then other class, we have other class like river bed. We got the excellent result 0.9. It's very difficult to prepare, but we got the excellent result 0.98. And for water body, we got excellent result when you combine first date and second date. We got the perfect result 1, right? So coming to the now our main target, the crops. So wheat, see wheat, it is, we got the excellent result 0.94. So 94% accuracy we got in case of in case of GBT, and here see the same result we got 0.94. So for wheat crop, we can use any technique. There is no differentiation, no deviation in result. So we can use either GBT and we can use either RF technique. We can also use, see here the accuracy when you use the SAR data 0.86. Okay, when you use the optical data set 0.86, both are same. So when you fuse these two data set, then it is increased by 94%, right? Now problem is with the master data set. See here the master data set we got when you use the SAR data set, we got only 0.08, so 8% accuracy only. But when fuse it, it increased by 62%. So it is satisfactory. Okay, master accuracy 0.62 is satisfactory, but in case of RF, it is not satisfactory. It yielded very poor result 0.32. So we have to use the gradient boosting tree. We have to combine. We have to fuse SAR and optical data set if we want to prepare the master crop mapping, right? For sugarcane, it's yielded a good result when you combine date 1 and date 2 data set, and it was yielded 0.94, so 94% accuracy we got. So so that's why we need other technique to prepare the master's mapping, right? So the features importance here, you can see I told earlier, if we combine the VB, VAs, then if you combine the 10 data set, then all together we have 36 bands. From this 36 band, here VB, VB vertical volumetric for date 1 is most important band. For GBT 16%. So now we can use here the PCA. We can use the dimension. If we reduce the dimension, maybe our result will be increased. That is the future task. It should use PCA-based analysis. It should reduce the noise, because there is a less than 1% importance this band. So this band is not actually required for preparing the GBT, but for RF, all the bands are almost equally important. So we cannot ignore any band. But for GBT, we can ignore this band, because I have used the freely available data. But if you want to pasteurize the data set, high spatial resolution data, then you have to think minimum data set requirement, right? So coming to the conclusion, obviously, when I use a SAR and optical data set, it improves the classification of any crop. It improves all the crop classification techniques, right? But the GBT perform better than RF across all classification technique, and we cannot ignore the date 3 data. We need to use at least 3 date 1, date 2, and date 3 based on the region, based on the cropping calendar. You have to select this date, and definitely this type of analysis help to government for crop monitoring, for planning, for food security, many things, maybe for launching various government program, right? So this is requirement of our nations to prepare to early predict the crop. Okay, ISRO now doing this work. Okay, so in future, what we can do it? I thought I will extend this result. I'll include the Kharif season also, because this is a Uttarakhand, so there's a very difficult to get optical data set in Kharif season. But I'll use the SAR data set to prepare because it's a rice and wheat based area. So definitely I'll extend this and the rice crop mapping using in Kharif season, and we can integrate other machine learning model. Actually, I have used other technique like SVM map. SVM not yielded a good result, that's why I remove it. But we can use the deep learning technique. We can check it is increase or decrease. Then we can incorporate NDVI, basically CV of NDVI, then VS and VB ratio, then backscatter texture. Okay, because in case of NDVI, in case of a stable land use, there is no variation in NDVI, but in agriculture field, variation of NDVI is very high. So based on the CV of NDVI, coefficient variation of NDVI, we can recognize the agricultural land. Okay, so thank you. Obviously, in future, I'll try this combination. I'll try to improve the crop classification technique. Thank you so much. If you have any question, any query, then you can ask now. Hello?
Thank you, sir.
Yeah. Thank you.
Thank you, sir. Thank you, sir, for your nice presentation.
Thank you. Thank you so much. If
Sir,
you
also
any
we have,
query, yeah.
that means the presentation was good. That means your association with the conference was very nice. So we will thankful to you. Myself, Dr. Sutiranjan Mishra, convener, and Dr.
Okay,
Shobhan Shankar. Then
yes, yes.
we have discussed we should have a formal meeting with.
Surely, sir. Surely. After the conference, we have done very good work. So after the conference, definitely we will meet. We will talk regarding the publication, regarding other things.